Welcome back to Iowagen USA Tito Tattoo Day. We are here now at Cosi Science Festival sponsored by Battelle. The other side? My husband works at Battelle and volunteered us to help out at the Battelle sponsored Cosi Science Festival. You want this? Why we have money?
Brought the girls. We actually made it pretty far up until they made us turn around and go back. The girls.
Only about 100 people died there. Only about 100 people died there. Only about 100 people died there today.
Oh, this is what we can see.
Look at that. All right. So, when you're at home, who here has boiled a pot of water? When you're boiling a pot of water, you see the water starts to bubble, right? So that's water changing from a liquid to a gas. If you were to cool that gas down, that gas water would then become a liquid again. In this case, with our liquid nitrogen, that nitrogen is so cold that as soon as it touches the bowl, it starts to evaporate. It starts to vaporize. This is called a phase change. So today, we've got a few fun objects here. We've got some roses, we've got some bananas, and we've got some marshmallows. And we're gonna find out what happens when we stick these into the liquid nitrogen.
Would somebody like to come up and feel to make sure this is just a regular rose? Yeah, you wanna come up? Just feel it, just make sure it's a normal rose. It's soft, or what's it feel like?
Here. You wanna confirm for me?
It's soft, feels normal?
All right, it feels pretty soft, right? Pretty soft?
Okay, you wanna ask what's gonna happen?
All right, so who has a hypothesis for what's gonna happen when we stick these roses into the liquid nitrogen? What do we think? They're gonna freeze and then maybe shatter and break. So as scientists, it's really important for us to have a hypothesis or an idea, a guess, an educated guess of what's going to happen when we do an experiment. So Cole has dipped our flowers in the nitrogen, and then let's see what happens. Look how they unfurl.
So first you can see that they've kind of bloomed, quote unquote. And that's because whenever the liquid water that is inside the actual rose petals freezes, it expands because it becomes a solid, making the rose petal bloom, as you can see. Can we get 2 volunteers to get some gloves and come up here? All right, you.
All right, I see one volunteer right here and one over here.
Nick, I'll hand you these.
So we'll hand you some safety gloves. It's very important to be safe when we're doing our experiments. Flowers were pretty soft, right? So let's see what happens this time. Go ahead and give that a squeeze for me and see what happens. Just crush it together. Crush it as best as you can. Look at that.
Whoa, look at that.
All right, a lot easier to break now, right? And like Cole said, that's because when we stick the flowers into the liquid nitrogen, all of the liquid inside is going to flash freeze, and they're going to become very brittle and easy to break. volunteer here in the purple that wanted to come up and shatter a flower. Are you ready? All right, go for it.
Whoa!
All right, great job, great job. So the next two things that we're putting into our liquid nitrogen here are marshmallows. So what do we think is going to happen? Who has a hypothesis of what's going to happen when we put our marshmallows? They're going to get cold and freeze. That's a good hypothesis. So our marshmallows, they have a lot of air trapped in them. They're very porous. They're not very dense. So any moisture in our marshmallows, as soon as we put them into the liquid nitrogen, it's going to start to freeze, just like our flowers. So when we take these out, we're going to see these marshmallows are pretty squishy, right? Whenever you guys have a marshmallow, you have it at a campfire, it gets real sticky and gooey. So we're going to see just how much more dense and rough these are going to be. Look at that. So now if you hit it, it's kind of like a hammer. And that's because any moisture, any air trapped in there, it's been frozen by our nitrogen. Now if we were to take a hammer, we can see just how much that's going to shatter. Now this one wasn't in the nitrogen for too long, so this might not shatter too much, but we'll definitely see it crack.
Whoa!
Look at that. So with our other two marshmallows, they've been sitting in the liquid nitrogen a little bit longer. So we're going to try and see if those are going to have a little bit bigger of a shatter when we hit them. All right, can I get one volunteer to hit my marshmallow here? So I see one volunteer here in the red. We're going to count to 3, and then we're going to have you shatter it. Are you ready? 3,
2, 1,
go.
Yeah, there you go.
All right, all right.
Good job.
Great job.
This one's very brittle.
Snaps right in half. And that's because, much like our flower, that banana peel is going to have a lot of liquid trapped in it in all of its cells. So when we put in that liquid nitrogen, it's going to be able to flash freeze just the same, and we can snap it right in half. Yep. We're going to need a couple more volunteers out there. Let's get you in the tie-dye shirt. Let's take some green gloves, and then 3, 2, 1, go for it.
Whoa!
Look how easy that is.
I know, snap one.
All right. So our volunteer in the orange gloves, you want to pick that up for me and snap it in half? Go ahead and snap it in half. Really easy, right? All right. Let's see what happens when we take a hammer to the banana. Right here, buddy. It's a lot tougher, isn't it? Right?
And then Nick will have you do the
Does anyone have a hypothesis on why it's tougher to smash a banana than it is the flower or the marshmallow? What do you think? Because it's a fruit? So it's, even with some other fruits, you can see with our banana peel, like that's still part of the fruit, it snaps pretty easy, right? So our banana has a lot of starch and it's a lot more dense than our flower, so it's a lot harder for it to freeze completely shatter.
I'm gonna have you do this one, Nick.
We got one more. All right, so let's get our volunteer in the orange gloves, right?
All right, the last volunteer here.
3,
2,
1, swing it.
Oh, look at that!
Great job, great job. We've seen a couple things, we've smashed some fruit, but we're gonna see what happens one more time when our liquid nitrogen contacts a surface of something that's really warm, like pavement, for example, on this beautiful 70-degree day. So if I can have everybody stand back behind this black pavement just to the left here, Cole is going to come over to the right of the stage, and we're going to have one more demo. All right, so I'm going to need everybody's help in the crowd. We're going to count down from 5, and Cole is going to roll out the liquid nitrogen, and we're going to see it vaporize immediately. All right, everybody, ready for the countdown? All right, we're going to count down 5, 4, 3, 2, 1, go! All right, look at it vaporize immediately. Thank you everybody so much for coming out today. Please feel free to check out inside the tent. We got a bunch more fun booths and things to do, and then Battelle will be on the main stage this afternoon, I believe at 4 o'clock. 4:30, so be sure to check us out there.
Yeah, I got bling.
Hey, how you doing?
All right, how much sell?
Good. What have you been?
How about that, babe?
Oh yeah, very good. Come here. 1, 2. What is that face? All right.
Do you want your pictures taken together?
Yeah. if you
Yes,
don't mind.
please.
All right, that was pretty good. So here's what we're gonna do. We're gonna do a countdown from 5. 5, 4, 3, 2.
And thank you for watching.